So yep, it's recording right now. So if you have any comments, go ahead. If you guys want to say hi to Wyatt, because Wyatt's really the reason I started recording this, you can say hi to Wyatt. But Wyatt, you're missing out on the Christmas tree and the Christmas lights that Caitlin broke last hour. But that's okay. Yes, you did. They don't.
No,
do these work?
Are
these working?
I put them on.
They were working just
No,
fine.
weren't.
You put them up and they're not working.
Okay, I won't help you ever again.
Fine. That's a lie. Because I always have apples in here.
Nuh-uh.
All right.
I haven't had them since then.
What's wrong with salt? Who puts salt in their apples? Anybody?
Ew. No one.
Hunter, you're a good guy. You're a good guy, Connor. Does anybody put salt in their watermelon?
Oh yeah.
Oh, yeah.
That's a little different.
Okay.
That's a little.
Why would you do that?
Yeah, wait,
It's good.
It brings out the flavor.
sweet.
No, I tried it one time. It's disgusting.
Oh.
It's
It's like sweet and sassy, right? All right. Let's get focused here. I've had enough fun made of me this weekend already. I don't need any more today. Guys, 5.4 is going to talk about special trig values of special angles. And if you have your unit circle handy, this is going to be so simple. Is there anybody that needs an extra copy of that unit circle at all? Everybody's got theirs? All right. Hey, guys, today our goal is to find exact values of trig functions. Now, when I start talking exact values, I mean leave stuff in like radical form. You might have some square roots left in it, like we did on those last 6 answers on the quiz from the other day. But we've got some special angles that we're going to talk about. And what we do is we call these reference angles. And our reference angles that we're really going to point out today are going to be the following angles. They're going to be 0 degrees, 30 degrees, 45, 60, and a 90-degree angle. Okay, and then we also want to talk about the radian counterparts that they would have. Okay, guys, take a look at your unit circle. Do you guys find your unit circle? In your unit circle, look at your first quadrant angles. Is 0 degrees listed in your first quadrant angle? Is 30 degrees listed? Do you have an angle for 45? Angle for 60? Angle for 90? Okay. I think you'll really understand this. But what we want to do is we want to start talking about special triangles. Have you guys talked about two triangles, 45, 45, 90? And then a 30, 60, 90 triangle before? Yes? You should have. Okay, a 45, 45, 90 is like half of a square cut diagonally in half. You guys remember that? Okay, here's the dealio. Guys, in the first quadrant, if you look at this first triangle that's formed right here, this is a 45, 45, 90 triangle, all right? It's basically half of a square. If you can imagine a square that's 1 by 1 on each side, if I cut that square in half right here, that 90-degree angle will be cut in half to what angle? 45 degrees, right? Okay. So the sides that we have right here in a 45, 45, 90 triangle are a 1 and a 1 as our legs. And then the hypotenuse is the square root of what? What's it say here? Square root of 2, okay? What I want to do quickly is this. I just want to prove something to you about your unit circle. Guys, this triangle right here, if I said that this was my angle theta right down here, all right? And that angle theta was referenced to the origin. If I asked you in this question, guys, what is the sine of our angle theta right here? What would you tell me in this triangle on the left? What would you say? What over what? Sine of this angle right here. What's the opposite leg? 1 over the hypotenuse of what? 1 over the square root of 2, which would be what value? Okay, so this is an equal 1 square root of 2 over 2 after I rationalize the denominator. Well, guys, what angle was theta in this example? How many degrees? So what this really says is the sine of 45 degrees is the exact value root 2 over what? Well, root 2 over 2, okay? So what I want you guys to do is this. On your unit circle for me real quickly. Go to 45 degrees on your unit circle. Can I use this here, Taylor? 45 degrees being right here. Everybody see the 45 degrees? Now keep in mind, out here your values for sine and cosine are already listed, aren't they? Understanding that the sine is the second value. What's it say the sine value of 45 degrees is there? What's it say for an answer? Root 2 over 2. Okay. Is there any point going through all this work right here if they're referenced right on your sheet here today? Not really. Okay. So take a look at that there. In a 45, 45, 90, let me ask you the question. What's the cosine going to be? Root 2 over 2 again, okay? All right, take a look at this one over here, this 30, 60, 90 triangle. I've got a 30-degree angle down here as theta, okay? Let's just write down two things here. I'm going to write down the cosine of 30 degrees right here. We'll get it off of this chart. And the sine of 30 degrees. Now I want you to understand something. Whoops, I screwed that up big time. Hang on a second. We're going to explore the cosine of 30 degrees right here. And we're going to explore the sine of 30 degrees right here. Okay? Now, do you guys understand how a 30, 60, 90 triangle comes about? Have you gotten this explanation before? I hope. Okay. Apparently that's a no, because you're looking at me like, what the hell are you talking about? All right, watch this. What kind of triangle have I got here? If I draw it correctly. Bad one. Let's try this. Oh, come on, lordy, lordy, lordy. Somebody put the forward sticker on this. Assume that's equilateral. Is that okay with everybody? All three sides being the same. Would you guys agree? Okay, just let me ask you this question. If this is a 1, then what would be true about these other sides if it's equal? All 1s, okay? And then equilateral triangles, what's going to be true about all three angles? All going to be the same, right? So you're going to have 60 here, 60 here, 60 here. Now if you can imagine this, if you can imagine me dropping an altitude right in here, what angles form down here between the altitude and the base? 90. And then this 60 gets cut in half as a 30-degree angle. So this triangle is really coming from a equilateral triangle getting cut in half. So do you see the 30, 60, 90 correlation here? Okay, check it out. If this was a 1 right here, what's the distance going to be from where the altitude intersects the base? If this distance was 1, what's this going to be? So what's the relationship of this is really my short leg. This is my short leg compared to the hypotenuse now on the left triangle. What's the ratio of the short leg to the hypotenuse? Is it just half its length? So if this was 12 right here, what would this be? 6. You understand that? Okay. So it just as an idea here. If I go back to this 30, 60, 90 idea that we're talking about, do you guys see this short leg right here of 1? We just said the short leg's half of the hypotenuse, didn't we? What do they label the hypotenuse as right here? 2. Okay, is the short leg half the hypotenuse? Okay, check it out. Where's the square root of 3 coming from? Well, square the 2 for me. What's 2 squared? 4. What's 1 squared? 1. You got a hypotenuse leg, so subtract the 4 and the 1. Where you at? What are you going to do to the 3 to get this other leg in? Square root it. Root 3. Okay, so let's talk about this as it relates to my 30-degree angle. Cosine of 30, what over what, gang? What's the adjacent leg in this? Root 3, isn't it? What's the hypotenuse? 2. Okay? Let's do the sine of 30 degrees. Sine of 30 degrees. What's the opposite leg to 30 degrees, kiddos? 1. Sine is opposite over hypotenuse, so 1 over what? Okay? Now my question to you, was any of this necessary for me to go through? Because if you look at your unit circle, find 30 degrees. That's a nice reference on your unit circle, isn't it? Okay, go out to the points out there that are in parentheses. What value is listed first? Root 3 over 2. And root 3 over 2 really corresponds to what? The cosine. And then?
Yeah, but isn't it sine then cosine?
It goes cosine, sine first.
Oh.
Remember, and the reason it's cosine, sine is because cosine's that adjacent leg to this right here, right, Jackie?
Yeah.
And cosine is defined as the adjacent leg over the hypotenuse. Would you buy that? And the adjacent leg is always the horizontal one here, okay? Good there?
Yeah.
So that's like the x value getting listed first, okay? You okay with that, kiddo?
Yeah.
All right. And just like this down here. Recall this unit circle. Remember these points out here are listed as what first? What's it say is listed first out here? The cosine value, then the sine value. Okay, are we all right with that? Okay. Notes kind of talk about, don't forget the plus, plus, minus, minus rule. Like what's positive where, what's negative where. I don't really get too concerned about that because honestly, you know how to do coterminal stuff, and I think that we should be good on this, but what I really would like to do is this. I'd like to kind of fill in this chart right here and see if we can't figure some stuff out. So I'm going to try and put some lines in here. You might want to do the best that you can as well. We're going to use our unit circle to answer some of these questions. Now guys, keep in mind, the unit circle only gives us what values? What two values? Sine and cosine. Does it give you tangent? Unit circle doesn't give you tangent, does it? You guys agree? Okay. What I would also put up here is the following. Don't forget this also. You might want to write this down. Don't forget that the tangent of any function is equal to the sine over what? Tangent of any function can also be the same as sine over what? So if I know the sine and I know the cosine, would we find the tangent of that angle then? Good. Okay, so let's I'm gonna fill the rest of this chart in. We're gonna answer these. Bloop. And your chart doesn't have to be perfect. Just draw some lines in there. Okay. Try and zoom up on this a little bit. Yes, I can. All right, let's start with our reference angle of pi right here, okay, guys? So find your angle pi, okay? That's clear over on the left in your unit circle, isn't it? Clear left in your unit circle. Let me find an image of the unit circle real quickly. Hang on 1 second, please. Is this the one you guys have right here? Does it look similar to this?
Yeah.
Pretty similar to that. Can you guys read that okay up there? Okay. So the first one we're going to talk about is going to be at pi radians, isn't it? Isn't pi radians over here? Okay, we got to find the sine and the cosine. Obviously, what's the cosine value going to be right here, Gary? -1. And what's the sine value going to be? 0. So I'm going to go back to my chart right here and say, you know what? What was the sine value again? 0. Cosine was -1. All right, hey, I got a question. How do I use those two values then to figure out the tangent value? Oh, other way. There. Sine divided by cosine, right? So sine divided by cosine, 0 divided by -1. What are you going to get for the tangent value out there then? Wouldn't this just be 0 divided by -1 here, kiddos? Which is equal to what value? 0. Yep, tangent of pi is 0. Okay. Let's see. We want the reciprocals of the three main functions. So how about cosecant? What's that the reciprocal of?
0. Or sine.
It's going to be the reciprocal of sine. Now, do you guys agree right here that sine is really 0 divided by 1 up top here? Would you guys agree with that? So if I reciprocate this, what are you going to have in the denominator for your cosecant? 0. So this is actually going to be an undefined. So here's kind of a general rule for you. You guys ready for this general rule? Anytime you have to reciprocate a 0, anytime you reciprocate a 0, the reciprocal of 0 is always going to be undefined. Does that make sense? If I reciprocate 0, it's always undefined. Okay? How about the secant? That's going to be the reciprocal of cosine, isn't it? What's the reciprocal of -1? Careful on that. -1 is the same as -1 over 1, isn't it? So if I switch them around, 1 divided by -1 would still be what value? -1. So the reciprocal of -1 would be still -1. All right, guys, if the tangent is 0, what's that mean about your cotangent? Undefined. Okay, good. Undefined. Guys okay with that first one? Starts out pretty easy, sine, cosine, doesn't it? And you have to use those two values to figure out the rest. Okay, so let's go to 30 degrees. Let's see if we can figure these out quickly. 30 degrees. At 30 degrees, what's your sine value up top? 1/2, right? And I'm going to go ahead and take a timeout here. Everybody understand where I'm getting these values off the unit circle? Anybody that's confused on where in the world are these values coming from? You guys understand you're all getting them from right here, right? Again, I'll just back right up here. If I go to the sine of 30 degrees, there's 30 degrees. Let's see, sine is the first one or second one listed. Okay? So go back here then. Tell me about the cosine of 30 degrees. What's that? Root 3 over 2. Okay, then we get into trouble. All of a sudden, what's the tangent? Okay, my tangent here. Guys, a tangent would be 1/2 divided by root 3 over 2, right? Everybody agree? It's like a fraction divided by a fraction. Now, when you're divided by fractions, that's the same as, what's the rule? Multiplying by the reciprocal. So in this tangent part right here, do you agree that the sine value is really 1/2 up top? So to divide by this root 3 over 2, I could multiply by 2 over what? Everybody agree with that? Everybody agree with that? Well, we're going to work our way through it. But you understand that instead of going this divided by this right here, I took 1/2 and left that alone. And then you understand dividing by root 3 over 2 is the same as timesing. Do I have the reciprocal right here? Do I have the reciprocal of what was up here? I do. Okay, now I'm going to erase this quickly to give myself some room. But guys, what would the 2's do to each other? So I'm really going to have 1 over what here? Root 3. 1 over root 3 is where we're at. Do I like my answer looking like that? Probably want to call it what then? Root 3 over 3 there. Okay. All right, so now it's just a matter of reciprocating for the rest. How about the cosecant? What's that going to be? 2 over what? Which is 2. How about your secant? Where are you at? 2, yeah, this would be 2 divided by root 3. I'll kind of do the work here. 2 divided by root 3 if I reciprocate, which would be 2 root 3 over 3. And then finally, how about the cotangent? We had 1 over root 3 here, so this would just be root 3. Okay. So I want to see how good we are here quickly. Let's do this. Let's have the boys do part C there, and we'll talk about it. Girls, you've got part D. All right. Boys, you have part C. Girls, you have part D. When you get done, check with someone around you. Okay, I'll give you about a minute or two here, and then boys, who's talking for the boys? Who's the spokesperson for the boys? Jace, you've been nominated. Who's spokesperson for the girls?
Jackie.
Jackie, you've been nominated. Okay. All right.
Okay, Cole's the spokesperson. That wasn't me.
It's from the kid whose dog's got one eye.
Sad.
I'm still alive.
I know.
Is he doing better?
Yeah, except he won't eat for some reason.
Oh no.
He should be good. I still think he likes the dog. He's tired of you doing that.
It's just picky.
He'd rather eat cat food, I know that.
Are you kidding me?
Yeah, but we won't let him.
Hilarious.
Dog food? Dog food? No, it's not. So what should I get? What should I get?
we coming along here? Good?
Only I can.
Girls doing okay? Jackie, does your group need more time?
I'm done. I guess I'm like, should I like check with people?
Yeah, go check with them.
I'd go with John.
Jace, are we good? Thanks. Mhm. Square root of 2. Obviously, you're square root of 2, like square root of 2. Yeah. So that's what they want. Secant 1 over 2, yeah.
John's right. Yeah, we got
All right, Jace, talk to me about the sine value. What'd you get?
Square root of 2 over 2.
I agree. Square root of 2 over 2. Very good. How about your cosine?
Square root of 2 over 2.
All right, square root of 2 over 2. Now, here's the nice thing about this. What was true about the sine and the cosine? They were exactly the same. Think about it for tangent. If I'm taking sine divided by cosine, what's 5 divided by 5?
1.
What's 10 divided by 10? What's one thing divided by the same thing? 1, right? So if I took sine and divided by cosine, one thing divided by the same thing, what'd you get for tangent, kiddo? 1. All right, very good. Okay. How about your cosecant then? Reciprocate your sine.
Square root of 2.
Square root of 2. And now, I just want to point something out here. Do you guys agree that reciprocating meant that this is really 2 over root 2? Would you guys buy that? But I don't want to have an irrational in the denominator, so we'll rationalize this. This would become 2 root 2 over what then?
2.
What happens to the 2's right here and here? They would cancel, so you're just left with what value? Square root of 2 then. I agree. Excellent. How about the secant there? Same thing. Square root of 2. And then how about your cotangent? Excellent work, guys. Okay. Jackie, you ready, buddy?
Yeah.
Okay, sine value at 120.
Root of 3 over 2.
Root 3 over 2. What's cosine?
Negative half.
Negative 1/2.
Negative root 3.
Negative root 3. This divided by this, right? Or this times the reciprocal. The 2's would have canceled for reciprocating, and then this would have been negative root 3. Good. How about your cosecant?
Would have been 2 root 3 over 3.
Good. And how about your secant?
Negative 2.
Okay, I agree. And finally, your cotangent.
Negative root 3 over 3.
Excellent, you guys. Do you guys have any questions about what we just did here?
So who won?
The tie. You guys have an arm wrestling match right now to see who.
That'd be pretty close.
I doubt it.
What?
Jackie's got some guns.
Think so?
Yeah.
All right. You guys feeling okay about that chart right there and how to read this? Yes, no, yes. Good? Okay. By the way, how many had, boys, how many are okay with this right here? Girls okay with this one here? Okay, make sure you've got them down, okay? All right, so what I'd really like to do then is just to get down with A, B, and C here, and we'll get rolling here, all right? So guys, here's what starts happening here. We got to find some exact values, and this is really pretty simple to do. The first one that's listed here is sine of 7 pi over 4. Now guys, I don't talk too much about negative angles right here, but I think that we can talk coterminally here in a second. But guys, does 7 pi over 4 show up anywhere there on your unit circle? Which quadrant is 7 pi over 4 in? Everybody see it listed in quadrant 4? So if I wanted the sine value there, what do you have? What's it say the sine value is? Negative root 2 over? Negative root 2 over 2, right? Okay, next one I want is tangent of negative 8 pi over 3. All right, here's the deal. First of all, do we even have negative angles on that unit circle anywhere? Are there any negative angles on that unit circle?
No.
All right, so probably it'd be a good idea to go coterminal and find a coterminal angle, wouldn't it? Okay. One revolution for coterminal angles is how many radians to add to this situation? 2 pi radians, right? So that's the same as 2 pi over 1, but what's my denominator in part B?
3.
So I would have to add how many pi over 3?
6.
Got to get a common denominator when I start adding fractions. Do you guys agree that this is still 2 pi right here? So do you really agree that this is adding the whole revolution? So how about, you talk to me right here. Negative 8 pi plus 6 pi in your numerator. Where are you at? So this is negative 2 pi over 3, isn't it? Still negative, so add another revolution. Where your denominator is 3. I'm going to add a 6 pi over 3 again. Okay, that puts me at 4 pi over 3, doesn't it, gang? All right, so when I get to this point right here, now keep in mind, what we're trying to do is find the tangent of negative 8 pi over 3. We said go terminally. This would be the same as finding the tangent of what angle now, guys? We're looking for the tangent of 4 pi over what? 3. Is the tangent listed on your unit circle?
No.
No, but is there enough information at 4 pi over 3 to determine what the tangent would be? Yeah, sine divided by what? Okay, so find your angle. 4 pi over 3. Which quadrant are you in? Quadrant number 3, I hope, right? Okay, so in quadrant number 3, let's do the sine over the cosine to evaluate this. So what's the sine value at 4 pi over 3? So we're going to go negative root 3 over 2. And let me guess, you're dividing by another fraction, aren't you? Isn't the cosine negative 1/2 there? But I don't want to divide by negative 1/2. I want to multiply by its. So really we're going to multiply this by negative 2 over what? Quick question here. What are the 2's really going to do to each other? The 2's will really cancel, and you really have a situation where you have a negative times a negative, right? Which makes this a positive, so it's going to be positive root 3 over 1, which would just be root 3. Okay? Well, that does not look very nice. What do you think? If you have negative angles, go coterminal till you get positive. Find your reference on your unit circle, do your work. Feeling okay about that? Any questions about the first 2? Okay, you try the next one, and then Jace and Jackie, you guys collaboratively figure out who's going to talk for part C, okay? No. You guys can talk together to pick one person other than yourselves as to who's going to talk you through this one. John, you've been nominated. So I want the secant of negative 13 pi over 4. Let's see. Keep in mind 2 things. Get this to be a positive angle first. That falls between 0 and 2 pi. And secondly, don't forget secant is a reciprocal of what? Cosine. So it might do you good to get a coterminal angle, figure out the cosine, and then do what with that answer? Reciprocated, okay? I like that word, reciprocate. You're not reciprocating. My wife says that a lot to me. But you're not reciprocating. You know what that means? She does all the work and I do none at the house. She does all the laundry. I don't reciprocate. Although I did put up over 5,000 Christmas lights on the house this weekend. The Christmas tree has like, the apple tree has like 3,000 lights in it. like 3,000 of those in there.
Did you break any of those lights too?
They all work for some reason. Funny, you haven't touched them. That's gonna work. I know that's gonna work. Johnny, you ready to rock and roll?
Oh, slow down.
We're gonna have to go over
Are you
this.
done, John?
We will. Let me see if I know the answer.
You just want the answer.
What did you get for the fridge box?
I got it.
Oh look, it's what you thought. She just changed it. But I
What'd you say?
saw like I saw the other
You put it in. It's always so easy to me. I don't know why. Well, I do know. I think I do know why. You know what's sick? I better explain
So why'd you decide to do
I
that?
like chemistry. I really like physics too. Physics because it's all new. Although if you guys would take calc, you would take calc. Physics can be done. These are easier. Anti-derivatives with calc, way easier. It was. Just much more.
Really?
Yep. Okay, first of all, let me ask this question, guys. What's your coterminal angle that you want to use? Or maybe I should say, what did your fraction look like when you were adding whole revolutions? What did you plus to this? 8 pi over 4. Yep, you got to establish common denominator. So the first time I add, you're at negative 5 pi over 4. So I've got to add again. We're still negative. I'm going to add 8 pi over 4 again, which would be negative 3 pi over 4. I'm sorry, positive 3 pi over 4. Guys, correct me if I'm wrong, but I think that angle lies in the second quadrant, doesn't it? Okay, so what I'm really looking to find here, this is the same as finding the secant of a coterminal angle, which we established as 3 pi over 4 on the unit circle. So if I look at my unit circle, let's see, the secant. I don't know what the secant is right off the bat because it's not listed on unit circle, but I do know that the secant is the reciprocal of the cosine, right? So quickly, if I go to my unit circle here, let's see, 3 pi over 4 right here in red. Cosine, negative root 2 over 2, isn't it? So couldn't I take the reciprocal of that and call it negative 2 over root 2 right off the bat and then work with it to rationalize it? Everyone agree? Okay, so I'm going to flip this. When I get back to my page, I'm going to write negative 2 over what? Root 2. So let's do that. This is the same as,
Wait, why are we? Oh, never mind. My bad.
okay, we're reciprocating it because we have the secant, right?
Yeah.
And we know enough, Jace, that the secant is the reciprocal of cosine. So once I do cosine, I can flip that to be a secant, right?
Yeah, I flipped those two around on the.
Oh, going left to right,
Yeah.
me? Okay. All right, so I don't like my answer like this, so we're going to rationalize root 2 and root 2. And we've got negative 2 root 2 over 2, in which case these 2's will do what to each other? Boom. And we're just left with negative root 2. I'm just curious, how many had negative root 2 as your solution there? Okay, good. Good. All right. Jaden, you'll let Wyatt know that I recorded this. I'll upload it if that's all right. It'll just tell him go to my home page and click on the YouTube lesson link, and it'll say integrated 3 5.4 lessons. All right. Okay, go ahead and stop this. Are you guys okay?